I hear 4 unrolls to schedule this with no delays on a 2-processor machine, or a dual-threaded machine, whatever you want to call it, dual pipeline. Anybody do better?
2.
I can name that tune in 1. I don't need to unroll at all.
Oh, that's right, because...
It's a 2-processor machine.
Right. Right.
So this is pipeline 1, this is pipeline 2. Right? 5 and 6 have to go like that. 9 and 10 have to go here. 8 has to go after 6, and 7 has to go after 5. Done. No worries.
If we had a 3-processor machine, then we'd have no ops.
Could I do this with a 3-processor machine?
Yeah, I mean, you get 5 and 9.
5 and 6 still have to go like that, don't they? And I still have this 1 and 10 thing going on.
What's 1?
Or what, 9. Sorry.
Oh, I see what you did there.
This one cannot update before that one reads, but it won't. The issue is this one's the write from here cannot beat the read from here, but the read happens at the start of the cycle, the write happens at the end. The fact that they're on the same pipeline machine, multi-pipeline machine, means they're all operating off the same clock. This one cannot get to its answer before that one starts reading. They both read the data at the same time. So it's impossible for this one to do. I can schedule them in this setup. I can schedule them parallel. I just can't put 7 before it. That's the whole point of a write after read. The write has to stay after the read. Well, the read happens at the start of this cycle. The write happens at the end. They're still safe. If you moved it one cycle before, if I flipped 7 and 8, I'd be doomed. 7 would be fine, 8 would screw it up. So I'm still okay with 3. So I got a 3 times speed up, 100% efficiency. No unrolling necessary. If I don't need to unroll, I don't unroll. What if I had a 3-processor machine and I said that between memory operations there's a delay of 2 cycles?
Now we unroll.
Now I got an issue, right? Because I got X, 6. At that point, I have to unroll. Do we agree?
Right. We get the same thing all across, right? Or, well, between 9 and 10 at least. 7 and 8 are right.
Okay. Do we agree this is a problem?
Right, it's inefficient.
I need space because I have to be able to write this up higher. Well, assuming that's, 2 blanks here and then the 6, I'd have to do 7, 8 like that, which means I need to do 9 and 10 like that because I can't put them any different. Now, under this case, what's up? What's my speed up?
Right now, it's
If I don't unroll, have I sped up?
No.
How long would it have taken me before?
We're taking you 1, 2, 3,
6 before.
6
How many cycles does it take me now?
2. Sorry, 1, 2, 3,
4.
2.5. 1.5.
Still, it's faster, right? It's not slower yet, but it sure ain't impressive, is it?
No.
Now, what if I started different pointers, and instead of doing this type of a decrementing here, I let them decrement 3 at a time. Right? And I started the R3, R2, I started at n minus 1. Right? Pointer plus n minus 1. And for the next one, my A version, I'm going to start them at the pointer and n minus 2. And then the B version of this, my third unroll, because I'm going to need 3 unrolls.
Right.
I start that one at n minus 3. So now they're all starting off shifted by 1. They all decrement by 3, so I'll move down, block of 3 at a time. Block of 3, block of 3, block of 3. It'll move down. There's no overlaps, no problems here. Would that work? They are independent of each other again, aren't they?
Yeah.
All right, so we had to slightly modify the code. I'll be using more registers, right? Because I'll need R2 and R3. All right. This thing is now going to be unrolled, so it's going to be jumping 3 at a time. So I'll have to have a new version of 3, 2, and 1. In the A version, I'll have whatever's the next one. I think I used up to 5. So I'll have whatever, 6, 7, 8, and then 9, 10, 11, or whatever. So I make some extra registers. Takes a few extra registers, I can now do it. But at that point, I can now go 5A, the extra minus 1 version, 7A,
9A,
9A, 5B, 7B, 9B. And then down here, I've got the rest of this. I've got 5A finishes out with 6A, and then 8A and 10A, and then I've got 6B, 7B, 6B, 8B, and 10B, with the appropriate changes of the new renumbered registers. And counting down by 3s as it goes. Now notice, from here to here, there's 2 in between. From here to here, there's 2 in between. From here to here, there's 2 in between. Everything's full.
right.
Efficiency means how many spaces have been filled versus how many spaces I had total. You get 100% efficiency if there's no blank spaces. Do I have any blank spaces?
No.
100% efficiency. That's nice.
But
How about my speed up? How many total instructions up here?
1, 2, 3, 4, 5, 18.
18, right? Just 3 by 6. Right? So it's 18 total instructions. How many cycles does it take?
6.
18 instructions in 6 cycles tells you.
You got the ideal speed up.
Yeah. Perfect efficiency, ideal speed up attained. It took 3 unrolls. Good? Awesome. Huh? That's loop unrolling.
Right.
That's it.
Yeah.
I mean,
Yeah, no, that's